Now representations of integers. For example, what is the base 8 expansion of 1, 2, 3, 4, 5 to the base 10? First divide 1, 2, 3, 4, 5 by 8. So here 1, 2, 3, 4, 5 is equal to 8 into 1, 5, 4, 3 plus 1, because when we divide 1, 2, 3, 4, 5 by 8, it gives 8 into 1, 5, 4, 3 plus 1. Here 1, 2, 3, 4, 5 is the dividend, 8 is the divisor, 1, 5, 4, 3 is the quotient, and 1 is the remainder. So here 1, 5, 4, 3 is equal to 8 into 192 and plus 7. Same 192 is equal to 8 into 24 plus 0. We are dividing basically again and again and again by 8. Same 24 equals 8 into 3 plus 0. Same 3 is equal to 8 into 0 plus 3. And the result is 1, 2, 3, 4, 5 base 10 is equal to 3, 0, 0, 7, 1 to the base 8. Here we are going from bottom to the top of the remainders. You can see here 3, 0, 0, 7, 1. Now representations of integers. The procedure base b expansion nb positive integers q n k 0 while q not equal to 0 and ak is equal to q mod b. So here q must be the integral part of q by b. Here k is congruent to k plus 1 and the base b expansion of n is ak minus 1 up to dot dot a1 a naught to the base b. And for the addition of integers, let a equals a n minus 1, a n minus 2, a 1, a naught to the base 2, and same for b equals b n minus 1, b n minus 2 up to dot dot p1 b naught 2. How can we add these two binary numbers? So first add this at their rightmost bits. Here what is this term bits? Bits is simply, you can see here, I am just 30071. These are called the bits. So here 1, 2, 3, 4, 5, total 5 bits are here. So now just we are adding the rightmost bits. A naught plus b naught is equal to c naught into 2 plus s naught, where s naught is the rightmost bit in the binary expansion of a plus b and c naught is the carry. Then add the next pair of bits and the carry. a1 plus b1 plus c naught is equal to c1 into 2 plus s1, where s1 is the next bit in the binary expansion of a plus b and c1 is the carry. So here continue this process until you obtain cn minus 1. The leading bit of the sum is sn equals a cn minus 1. The result is a plus b equals sn minus 1, s1, s naught 2. And here are some examples, like if a is equal to 1110 to the base 2 and b is equal to 1011 to the base 2, then a naught plus b naught is equal to 0 plus 1 equals 0 into 2 plus 1, so that c naught is equal to 0 and s naught is equal to 1. a1 plus b1 plus c naught is equal to 1 plus 1 plus 0, 1 into 2 plus 0, so c1 is equal to 0 and s1 is equal to 0. Same here, a2, b2 and c1. a2 plus b2 plus c1 is equal to, we are just adding the bits. 1 plus 0 plus 1 is equal to 1 into 2 plus 0, so c2 is equal to 1 and s2 is equal to 0. Same, a3 plus b3 plus c2 is equal to 1 plus 1 plus 1 is equal to 1 into 2 plus 1, so c3 is equal to 1 and s3 is equal to 1. Same, s4 is equal to c3 is equal to 1. Same, s is equal to a plus b 11001 to the base 2. Now we are doing addition of integers. How we do? So this is simple from the very basics. 7583 4932, and here we are adding 3 plus 2 5, 8 plus 3 1 1 and 5. So this is very simple, you can do. And here is the binary expansion 1011 to the base 2 plus 10102. So here 1 same 0 1 0 1, and here 10101 is the addition of binary expansions. Let A is equal to an minus 1, an minus 2 up to dot dot a1 a0 2, b is equal to bn minus 1, bn minus 2 dot dot b1 b0 2. How can we algorithmically add these two binary numbers? So here first add the rightmost bits, like a0 plus b0 is equal to c0 into 2 plus s0, where s0 is the rightmost bit in the binary expansion of a and b, and c0 is the carry. So then add the next pair of the bits and then carry. a1 plus b1 plus c0 is equal to c1 into 2 plus s1, where s1 is the next bit in the binary expansion of a plus b and c1 is the carry. And now continue this process until you obtain cn minus 1. The leading bit of the sum is sn is equal to cn minus 1. The result is a plus b equals sn minus 1, sn minus 2 up to dot dot s1 s0 to the base 2. For example, if a is equal to 1110 to the base 2 and b is equal to 1011 to the base 2, here a0 plus b0 is equal to 0 plus 1. Here we are using the rightmost bits. Here 0 is the rightmost bit of a and 1 is the rightmost bit of b. So here a0 plus b0 is equal to 0 plus 1 is equal to 0 into 2 plus 1, so that c0 is equal to 0 and s0 is equal to 1. And a1 plus b1 plus c0 is equal to 1 plus 1 plus 0 is equal to 1 into 2 plus 0. So c1 is equal to 1 and s1 is equal to 0. So a2 plus b2 plus c1 is equal to 1 plus 0 plus 1 is equal to 1 into 0, 1 to 2 plus 0, and c2 is equal to 1, h2 is equal to 0. So a3 plus b3 plus c2 is equal to 1 plus 1 plus 1 and 1 into 2 plus 1. So c3 is the carry 1 and s3 is equal to 1. So s4 is equal to c3 is equal to 1. So now s is equal to a plus b, and the result is 11001 to the base 2. Here 1